Hey all, today's talk is called Do Not Expose Your Users by Talking Too Much. And also I'm going to show you a timing attack, also known as side channel attack. Yeah, this presentation fits you that likes vibe coding, by the way. Who am I? My name is Douglas. I'm developing for the web with TypeScript for 5 years now at CodeMiner 42, and I'm a full stack developer at GoDaddy. And from time to time, I like to read postmortems to learn from the mistakes of my professional colleagues. Why bother watching this? If you're into AI-generated code, you should already know that every line that you commit to production is your responsibility and no one's else. So every decision that you put, every code that you generate, you should know what lies beneath. So you don't push security flaws by mistake. And also, if you're just getting started on software development, you will commit trivial mistakes. And also, not on the beginner level, I personally see many of the problems that I'm going to show today in applications that I use on a daily basis. And also, you would say you will notice in a bit that, oh, I'm just providing rich error messages to my customers. But yeah, as they say, the road to hell is paved with good intentions. If you search for post-mortem on security breaches concern, you will find documents to understand decisions that led to a failure in production. Also, if you search for leakage exposes users, you will notice that web applications can and will be breached, and it's just a matter of time. In some businesses, privacy is a matter of life and death, such as exposing your customers' data can lead to impacts such as from financial impacts to social impacts. I really recommend you to take some time to think how you handle your users' data and what's the impact on their lives if your data, the data that you collected, leaks. The problem that I'm going to show you departs from a simple login form, such as this, a simple login form that takes an email and a password, and a simple login controller. The login controller here, I made it with Adonis. So the first method, the method show, will just render the form that we saw, and the second method we will break it in parts. First, we will extract the email and the password from the form that we saw before. Then, from that email, we will try to find a user, and if the user does not exist on our database, it's pretty straightforward to return user not found, right? Also, if the user is found, then we will try to validate their password. If the password is not valid, we will show them a message, wrong password. That will help them to try another password. Uh, so they know they are registered on our platform with that email address, but they just missed the password. They just forgot the password, perhaps. And lastly, if the user exists and the password is valid, we will prompt them that the login was successful, right? Pretty straightforward. If the user is not found, we will warn them the user does not exist. If the password is not valid, we will tell them to try another password. Otherwise, the user hit the jackpot and made the login successfully. Here I have a bootstrapped Adonis.js application that renders a view, the login form that we saw before, and I also seeded a couple of users in my application. Also, I have this login controller similar to what we saw in the presentation with a few tweaks that I'm going to show in a bit. But the focus here, let's see how it behaves on the user perspective. The first thing that the user sees when accessing our application, he will see the login form with an email and a password. He will try foo@bar.com, a password that doesn't matter, and try to submit this. Oh, the user is not found. Good. So he will try another example. Then he looked the email from somewhere like Anna at example.com, and then he will try to input a password that doesn't matter. Oh, wrong password. That's a different error message. Before, he had a user not found. Now he does have a wrong password error. That gives me a hint that the email that I had, anna@example.com, is a valid email actually. So if we try another email like Bob and then try input a password, oh, Bob is also registered. Perhaps Charles. Example. Yeah, Charles is not registered. So you notice that we can start extracting information from this logging form merely with the response it gives us. So that's actually a problem. How do we handle that? We can go to the controller to check that out. Right. So looking at how our code works, if I don't bother this time operation here. It's just a wrapper to measure how long a step takes to execute. We will look into it in a bit. But what I wanted to bring here is this part here and perhaps this part here, the two messages that we saw while interacting with our login form. If we do not find the user, we say the user is not found. If we do not uh, find the password as valid, we will say to the user that he must try a different password. We probably don't want that. We probably want a standardized message for both cases, right? We don't want to give that the user is not found or the password is wrong. We could have like a default message that says uh, like invalid user or password. That could do it, right? It's a message that doesn't give what's going on. And right now we should have more a safer response that doesn't give which users are registered within our application. Let's try once more. Right, let's refresh the login form. Try once more, who@bar.com, 123, and yeah, invalid user or password. Good. What if we try Anna's email that we know that is registered in our database? Yep, same response. Good. But there is something hacky that we can do and find out more information on about our application. So let's try. I will try to log in with foo@bar.com and then with this invalid password, I will try to log in. Right. Got some requests on my DevTools that if we go here to the timing tab, we see that it took 13 milliseconds to respond. Let's try an email that we already know that exists. Oh, we got way longer response time, 46 milliseconds. What if we try, I don't know, bob@example.com? Right, 63 milliseconds. Good. If we try another gibberish email, what do we get? Oh, way shorter response time. Although the message that we receive doesn't give which users are registered on the database, the network, if we go deeper, we hack a bit, we will notice that there is a difference between two requests, how two requests are being responded by the server. That's not desirable. Let's check why that happens. Looking at the implementation, we have some asynchronous operations, such as we will find the user by their email, and then we will, if this conditional enters, it will early return. Otherwise, it will pass to the next step that is calculating the hash of a password. At this point, you should already know that hash is a intrinsically slow operation. It's slow by design. It's supposed to be slow, so one does not brute force your password, and thus by the process of the process of password verification is heavy by default. It takes a while to verify the password. It should hash the password and compare with the hash that we have stored in our database. So this should be the heaviest operation that we have. This one should have a wave out as well, such as a network call. And yeah, we should have some leads now on what might be delaying the response. So we have the difference between them. Look here. We tried to look up the user full at bar. We got 87 milliseconds and it never got to verify the password. And then when we wanted to verify the Anna at example.com, we took 1 millisecond to fetch the user from the database and 51 milliseconds to calculate the password hash. Also, that occurred similarly to Bob. And yeah, pretty much it. When we have a user that is on our database, the step to verify their password takes a while and gives a hint on the user was found and some operation is being done upon the database entry. By reading the Adonis.js documentation, it has explicit example on not to do what we just did. It basically tries to do the same thing. Find the user, and if the user exists, it will try to find the hash for that user, and then will do whatever it needs to do. So this is not the recommended practice. How do we how could we handle that to minimize the attack surface? We could try to hash the password even if the user does not exist. We would simply waste time before returning the response to the user. Here we just waste time by hashing the password that the user tried to input to us, and then we will return the error for them. If we try once more to log in with an invalid email or a valid email, and at example.com, we get the response of 59 seconds, and then we enter gibberish. We get similar response time, right? That's good. There's like before we had 13 milliseconds of response time against 60 milliseconds. Now we have pretty much the same amount of time on both requests. The one for the user that exists in our database and the other one that for the user that does not exist in our database. But rolling down the JS page a bit, we see that it already had it covered. Instead of doing those manual verifications, the Lucid.js ORM library that Adonis.js provides us already does provide this verify credential method that does a constant time operation on finding the user with the credentials that we pass to the function. Let's try that out. Instead of doing all these checks, we can replace everything like this. What I did here was to replace all that gibberish code with one simple call to verify credentials from the user class that I passed the email and the password. Otherwise, if the user is not found, it will throw an error. And then if there is an error, the verify credentials failed, or the user is not found, we will flash the default message that we have been seeing. Otherwise, the login was successful and we will see the login successful message. Let's try. Right, 63 milliseconds. 60 milliseconds. And I also actually know NS password. Let's try to log in. If I successfully log in, it will take around 60 milliseconds. So the discrepant amount of time it was taking on a failed to verify credentials versus a successfully verifying credentials or partially verifying credentials operation is now reduced. So the surface, attack surface is severely reduced now. Yep, that was it for today. Short tip on you for you to pay attention. And also I recommend you to search for leakages and security flaws that were addressed in the past. Recently, we had a few, so it's pretty interesting for us to develop better software to be paired up with what they're doing wrong for us to not to do the same. So thank you for watching and get in touch with us.